Good morning, students. In the last class, we have discussed with the different types related to alcohols, phenols, and we have discussed with one particular method in the preparation of an alcohol, and that method was by using alkenes. So today, let us discuss the second method for the preparation of alcohols, that is hydroboration and oxidation method. So here in hydroboration and oxidation method, borane reacts with alkene to form trialkyl boranes. So here one should know that borane reacts with alkene. So borane reacts with alkene to form a compound called as trialkyl boranes. And further, these trialkyl boranes on oxidation. So trialkyl boranes, again when subjected to oxidation, it gives alcohol as the major product. So how this is obtained, let us analyze. So first, in PUC first year, we have discussed a formula called as B2H6, which is known as diborane. So this diborane can be converted into borane by the formula BH3, where this BH3 is called as borane. So here the particular alcohol can be obtained by two different steps. So let us analyze these reactions. That is step 1. So in step 1, here propene will be involved in a reaction, that is CH3CH double bond CH2, which is known as propene. So this propene reacts with borane. So here I will write the borane as HBH2 as borane in the presence of THF. Here THF means it is called as tetrahydrofuran. So in this double bond which is present, which is nothing but a pi electron, this pi electron will shift on this respective carbon, because we know that secondary here there will be a formation of pi electrons on this carbon, where this pi electrons will abstract the hydrogen such that I will get CH3, CH2, single bond CH2 binded with BH2. So this is known as alkyl borane, because only one alkyl group is present along with BH2. This is known as alkyl borane. So this alkyl borane will again react with second molecule of propene. So when it again reacts with second molecule of propene, in this one of the hydrogen will be again abstracted by this pi electron, so that I can get what? CH3, CH2, one more CH2 two times, because here when this hydrogen gets abstracted, this becomes CH2, so that we are going to get what? CH3, CH2, CH2 twice, B along with H. This is known as dialkyl borane, because two alkyl groups are present. So this dialkyl borane will again react with one more molecule of propene, that is CH3CH double bond CH2. When it reacts with one more molecule of propene, again this pi electron will abstract this hydrogen, so that the formula or the final product will be CH3CH2 CH2, already 2, this is 1, 3, B. So this is known as a trialkyl borane. So this is first step where we have obtained a trialkyl borane. So in the second step, or in step 2, the trialkyl borane which is obtained, that is CH3, CH2, CH2 thrice with B, which is known as trialkyl borane. This trialkyl borane is subjected to oxidation by using hydrogen peroxide in the presence of a strong base as well as involvement of water molecule. When it is subjected to oxidation by using this hydrogen peroxide, we get 3 molecules of alcohol, that is CH3, CH2, CH2OH. Due to that reason, 3 moles of hydrogen peroxide is involved. Along with that, the left out component is boric acid, that is H3BO3, which is called as boric acid. So this is the second method by which an alcohol can be obtained. So after knowing this, let us move on to one more method called as third method. This third method for the preparation of alcohols can be obtained from carbonyl compounds. Hence, the third method is called as from carbonyl compounds. So, this is the third method by which an alcohols can be prepared by using carbonyl compounds. In that, the first subheading is the reduction of aldehydes. We have to study with reduction of aldehydes as well as reduction of ketones. So when we go through with the reduction of aldehydes or ketones, first we should know the reducing agents. So here there are many reducing agents that has to be known. So out of all this, the most important reducing agents are hydrogen can be used in the presence of nickel or platinum or palladium. This is one reducing agent. Or else I can also use sodium metal in the presence of ethyl alcohol. This is one reducing agent. Or else we can utilize lithium aluminum hydride, which is the strongest reducing agent. Or else we can also utilize sodium borohydride, that is NaBH4, as another reducing agents. So all these are considered as the strongest reducing agents. So by utilizing these reducing agents, when I utilize an aldehyde, so this is the general formula of an aldehyde. When aldehyde is subjected to reduction, you can use any one reducing agents that can be mentioned here. So when an aldehyde is subjected to reduction by using lithium aluminum hydride, so here reduction means what has to be added? Hydrogen has to be added. So here this hydrogen ionizes as H plus and H minus. When H minus attacks carbonyl carbon, the movement of electron takes place on oxygen. Oxygen becomes negative. The negative oxygen takes away H plus. Hence, I can rewrite it as RCH2OH, so that we can get what type of an alcohol? A primary alcohol. In the same way, when ketone is subjected to reduction, so that can be represented by the reaction R C double bond O single bond R dash. So when ketone is subjected to reduction, that is when it is added with hydrogen in the presence of a strongest reducing agent like lithium aluminum hydride. So again this hydrogen ionizes as H plus and H minus, where this H minus binds with carbonyl carbon. Movement of electron takes place on oxygen, so that O minus will take away one of the proton, so that I can write it as R single bond C with OH binded with one hydrogen along with R dash. So the alcohol which is obtained is considered as an secondary alcohol. So the meaning of this is, when an aldehyde or a ketone is subjected to reduction, aldehydes always gives a 1 degree alcohol or a primary alcohol, whereas the ketone will give a secondary alcohol. So the next one can be utilized by a name called as reduction of carboxylic acids, which is the fourth method. So let us write the heading as reduction of carboxylic acids. Reduction of carboxylic acids and esters is the fourth method by which an alcohol can be prepared. So here, when I consider a carboxylic acid which is represented by RCOOH, so when this carboxylic acid is subjected to reduction by using a strong reducing agent like lithium aluminum hydride, so here this carboxylic acid can be represented as what? RC double bond O single bond OH. So it is subjected to reduction means what? It has to be added with hydrogen. So when I take hydrogen, one will be H plus, another one will be H minus. So when binding takes place, this becomes what? Negatively charged. So this H plus will take away what? So it becomes OH, so that the intermediate will be obtained as RCOH H single bond OH. So when further it is again subjected to reduction by utilizing hydrogen, what I can write? Again it will split as H plus and H minus, where one of the OH gets eliminated, and here it will be H plus as well as H minus. This OH minus will take away what? H plus, hence what gets eliminated? Water molecule gets eliminated, so that we get an alcohol as RCH2OH. Hence, directly I can write it as, when an carboxylic acid is subjected to reduction, we get an alcohol called as an 1 degree alcohol or a primary alcohol. So here what is eliminated? Water molecule gets eliminated. So this is the explanation of the reaction.